Welcome, this is section 01, and we're going to talk about representing functions. This is a lot of review of some things that you saw in Algebra 1, mostly some terminology as it relates to functions and these things called relations. Make sure you have your note sheet, let me hold it up here, along with you to follow along as we go through the video. You'll see some definitions, some example problems, some we'll work through together, some I'll give you a chance to try on your own. Be sure to pause or rewind the video if need be, and also make sure if there's anything that's a little confusing as you're watching, jot down some notes for you to remind yourself to ask questions in class about that when we start to discuss this as a group. Okay, so let's start with a little bit of definition review, some vocabulary review, which is at the top of your note sheet. There's three words that you should have seen in Algebra 1 that we're going to review again with you. The first is a relation. So a relation is a set of ordered pairs. Basically what a relation is, it's a relationship between two different sets of numbers, your x coordinates and your y coordinates. And each of those has their own separate name. When we're talking about the x coordinates, that's the domain. So all of the x coordinates or all of the input values in a relationship or relation are known as the domain. The output values, the y coordinates that come out of the relation, are called your range. Okay? On your notes, you have an example problem. So this is a relationship here. The ordered pairs 3, 2, 4, 1, 6, 2, and 8, 0. So I want to know what is the domain and the range of this relationship. So to get my domain, I'm going to write a set. I'm going to put these brackets here to remind me that it's a set of numbers. And what numbers am I talking about if it's a domain? Talking about the x coordinates. So I'm just going to write those four numbers down. So the first ordered pair has an x coordinate of 3. The next one has a 4. The third point has an x coordinate of 6. And the fourth is at 8. So that set there is my domain for the given relation on your note sheet. Now to get the range, and I'm going to switch colors to do that. To get my range, I just look at the other numbers, the y values. So we have a 2, and we have a 1. Now we already wrote 2 in the list, so I don't have to write it again. And then a 0. So the red set is my domain, the black set is my range. Sometimes in the book, when you do problems and you check them in the back of your book, they'll put these sets in numerical order from least to greatest. So you could also write your range, like that, 0, 1, 2. I'm not that picky about that as long as everything is there. It is easier to check it if they're in numerical order, but as long as it's all there, I'm fine with it. Okay? Now, when it comes to representing relations, and in math, this is really key. A lot of different things in math can be represented multiple different ways. Relations are going to be pictured this year in 4 separate ways. And they're right all here on this slide. And if you see on your notes, you've got a 1, 2, 3, 4. We're going to fill in 1, 2, 3, 4. They correspond to the 1, 2, 3, 4 different ways I have represented this same relationship. So the first one is the one we just saw. A set of ordered pairs. And that's this. Okay? Now, another way we can depict this exact same relation is right here, number 2, a table. Now notice, each row of this table corresponds with a point in my set of ordered pairs. X is 1 when y is 2, x is 2 when y is 4, etc., etc. The third way to represent a relation is right here, these things with the ovals and the arrows. This is called, and this might be new, you probably saw it in Algebra 1, but just briefly, a mapping diagram. Why is it called a mapping diagram? Because we're taking all of our x values and mapping them using these blue arrows to their corresponding y coordinates. So the 1 with the arrow to the 2 means the point 1, 2, etc., etc., etc. They're not all going to necessarily point vertically like this. It just came out nice that all the x values and all the y values, when you write them in numerical order, they correspond. And you'll see what I mean when we look at some other examples of that in this presentation. And the final one, the big one, the one we're going to use a lot, besides probably tables, is a graph. And that is just each point on the graph represents a different ordered pair in our relationship. The graphs we'll be looking at more frequently this year won't have a set number of points, but rather it'll be a connected line or connected curve. But every one of those points represents a relationship in our relation. Okay? Now, changing gears and focusing a little bit more on graphs, if you look next on your note sheet, you see quadrants on the coordinate plane, and I gave you a blank coordinate plane. We're going to label that just to review where the quadrants are and what each quadrant means. So to start with, let's label our axes. Now, our horizontal axis is always the x-axis, the one that goes from left to right. The vertical, or the up and down, is always the y. Okay? Now, when it comes to labeling this, if you get stuck, the easiest way to do it is you start at the top right, and that's your first quadrant. Okay, so we'll start at the top right, and then we just go around the coordinate plane counterclockwise. So we move over, and that's our second quadrant. We go down to our third, and then we go to the right for our fourth quadrant. Okay, and we usually depict this with Roman numerals. Now, why is it a big deal about quadrants? Because A, it makes the graphing a lot easier if you understand the 4 quadrants. It also makes things easier because the points in each of these 4 quadrants all have the same, signs. And here's what I mean by that. In the first quadrant, okay, notice that all the x values on the x-axis are positive, and so are all the y values. Oh, because I forgot to label one other thing in case you forgot. Right here where the 2 points meet is our origin, 0, 0. Okay? It's just 2 number lines that kind of intersect at this point. So all the positive x's are along the right half of the line, and all the positive y's are at the top part. So anytime you see a point that has 2 positive coordinates, it's got to be somewhere in this first quadrant. Now, if we look at our second quadrant, here all the x coordinates are negative, but we're still above the origin on the y-axis, so the y coordinates are positive. All right, third quadrant, x is negative, but now so is y. So anytime you see a point where both coordinates are negative, it's got to be somewhere in the third quadrant. And then finally, the fourth quadrant, we have positive x's, but negative y's. Okay, that's important because you may see me some problems where they'll say something like, I don't know, where is 3, -4? And you look and you say, okay, the x is positive, but the y is negative. Oh, it must be in the fourth quadrant. Okay, and this isn't in your note sheet. This is just a little additional example of some things we're going to see in this section. All right? Okay, so we've talked about relations. We've looked at ways we can represent them. We've talked about domain and range. Now we're going to look at one final vocab word for this section, and it's huge, and it's basically what we're going to be studying all year long, and it's these things called functions. Okay, there's a lot here. I'm going to go through it one bullet at a time. As far as your notes, the definition for functions, because it says definition at the bottom of the front side, these 2 bold bullet points are what you need to be writing down. Okay? Functions are a special type of relation. It's kind of like that thing, bugs and insects, that little phrase you learned probably in grade school. I'm probably going to get it wrong, but it's not all bugs are insects, but all insects are bugs. Something like that. I may have flip-flopped it. Well, for math, all relations, I'm flip-flopping it now. All functions are relations, but not all relations are functions. Okay? They're special. Here's what makes a relation a function. What's in bold here that I want you to write down. It is where each element in the domain is mapped or paired. Mapped is the sophisticated algebra way of just saying the pair, with exactly one element in the range. So what that means is the x coordinates do not repeat. And we're going to talk a lot more this year about how to test whether or not a relation is a function. We'll get into that more in Chapter 2. But for right now, all you really need to know is the x coordinates can't repeat. All right, so let's do a little bit of work with identifying functions from relations and also throw in some of that domain and range stuff. So I've got 4 different examples. They're on the back side of your note sheet. We'll go through them together, and we'll see what we can do with them. So the directions say for each relation, identify the domain and range, then state whether or not we have a function. Okay, so the first one I gave you here is a mapping diagram. The left oval is always the x, the right oval is always the y's. To get the domain and range from a mapping diagram, all you do is you throw in all the numbers from the left into your domain and all the numbers from the right to your range. By the way, I didn't do this. If there was a number in one of these ovals that didn't have an arrow associated with it, like let's say I threw in a 3 here with no arrow, you wouldn't include the 3 because it's not part of the map, the actual mapping, which is the blue arrows, okay? Just a little heads up about that. I didn't do that here, but if I were, you'd still only use the ones that have arrows. Likewise, over here, if I put a 0 in here, you wouldn't include the 0 because notice how there's no arrow pointing to the 0. All right, now to check to see whether or not this is a function, we look at our x's. Do they repeat? And by that, I'm saying, is there more than one blue line coming out of any of these? I don't think so. So this is a function, because the x-coordinates do not repeat. All right, let's try the second one now. We have a table. So again, our domain is just all the numbers in the x column. We'll skip that -2 that repeats. We'll only write it once. So I see -5, -2, 3, and 4. And then my range is going to be 1, 2, 3, 4, 5, because that's all the numbers that are in the y column. Now to check for for relation being a function, I look and I see, do the x-coordinates repeat? Well, they do. They do right here. I've got a -2, 2 and a -2, 3. So this is not a function. Sad day. Okay? And the reason is because this -2 repeats in my x column. All right, let's just look at a couple more. Okay, so for the third one, I'll go back to black. For number 3, we've got a set of ordered pairs. Again, we just pull out the x-coordinates, the domain and range is just like we did earlier in this video. And then the range, we do the same thing with the y's. Now, is this a function? All right, well, let's look at the x-coordinates. Do they repeat? Now, don't get confused. By repeat, I mean repeat in another x-coordinate. I know -2 shows up again here, and I know 0 shows up again there. But as far as just the x numbers are concerned, the 5 numbers here do not repeat, so this is a function. Okay? Last one. This is a graph. Okay, we're going to assume that these are all by 1, so if I add some numbers to these tick marks, that might help us pull out the points. So when you have a graph, easiest thing to do is write them as coordinates. That looks like, whoop, I went backwards. Write them as coordinates. Remember, we always start with the x-coordinate first, so it's 2. And then the y-coordinate is 1. Okay, this point is 2, 2. The third point is 2, 3. And the last point is 2, 4. So now, it's basically just like problem 3, because now I have a set of ordered pairs. So my domain is just, well, there's only one x-coordinate used, and that's 2. I think we already know the answer for whether or not it's going to be a function. The range, however, there's 4 numbers used for the range. So is this a function? Well, I don't think so, because all the points have the same x-coordinate. A 2. This is not a function. Okay? So with that, we've covered everything you need to see in section 01. We're going to do some more practice with this in class. And with that, I